And that's it for housekeeping. Let's go ahead and talk about who's going to be presenting with us today. And I am joined by two super awesome esteemed colleagues. I'm like really, really excited today because I got Charity Majors and I got Jess Mink. These people are awesome. I joined Honeycomb largely in part because of Charity. I'm sure many of you probably follow her on Twitter. Jess Mink runs platform engineering for Honeycomb. And well, we're talking about the future of ops being platform engineering. So who better to have a conversation with Charity on this than Jess? I myself, I am Pierre Tessier. I run the solution architects team at Honeycomb, but if you have any questions, we'll be here for you throughout. And with that, I will let you two go ahead and take it off and go from here.
Pierre joined Honeycomb because I bribed him with scotch. That's how we get all of our best recruits. Let's see. I keep forgetting that I'm running the slides today. So platform engineering, eh? How many people do we have here?
130-ish.
Nice. Well, as Pierre said, if you have questions or complaints, or if you want to argue with us, please drop it in the chat. Don't save it till the end because you'll have forgotten what you wanted to ask by then. And questions and comments and arguments make this way more interesting for everyone. So platform engineering is really, I feel like, the natural next step in evolution. You know, we've been talking for years about sort of service ownership and, you know, software engineers writing and owning their code in production. And platform engineers, I feel, are what make that dream come true, what make that dream possible. But that naturally, you know, gives rise to the question, how is this actually any different from operations, which is, you know, what my background is in, or DevOps, or SREs. So we thought that we'd just kind of like go through those real quick. Ops, like in my perspective, like I know that like ops has a reputation among some people, developers, super annoying, who are like, ops is just shit work, right? It's all the crap that I don't want to do, that somebody else should have to do so that I can just write code up in my ivory tower. And that really pisses me off because it's actually, it's the, you know, if business is the why you're building it or what you're building, and, you know, and dev is the how you're, or the what you're building, why, what. Ops is the how, right? You don't have users unless you're delivering your value to those users. And that's where operations engineering is. It's a specialized skill set. It is an area of expertise, but it's also something that like can't be one team or one person's responsibility. It is, you know, the confluence of everyone who cares about the business succeeding cares about operations and doing it well. DevOps, again, there's a lot of sloppiness when it comes to like language, and the last thing I want to do here is get into a terminology war, but like DevOps is, you know, kind of the cultural practices and tools, you know, that happen when you've got a dev team and an ops team and you want to have empathy for each other and you want to work together instead of just lobbing software like over the wall. I built this, you run it. And SRE, I feel like is as Liz says, Class SRE implements DevOps. It's the very googly type heritage of, you know, applying software engineering techniques to running systems at scale. But all of these definitions kind of assume that there is a split between dev and ops, right? That there's separate teams, separate roles, and you're collaborating and everything. But like, what happens if that divide no longer exists? And this is what I think is so fascinating. Platform engineering is for a world where this is table stakes. This is no longer controversial. This is no longer something we have to argue about. This is something we're hiring for, and we're promoting for, and we're instilling in our engineering teams every day. Every engineer writes code, and everybody operates the code that they write. And this doesn't mean that there can't be any specialization, right, Jess?
Yeah, it doesn't mean there's not specialization, and it doesn't mean that you don't have people who are really good at this type of thing going around helping people, right? Like, just like not everyone is deep in the front end, right? Like you can have a heterogeneous team.
Absolutely. And like if you're someone who comes from like the ops / DevOps side of the world, like I am, I feel like there's currently like this real bifurcation that's happening along the infrastructure axis, which is, you know, if you love infrastructure, you can kind of do one of two things. You can either do the infrastructure, or you can use your infrastructure skills to help other teams do as little infrastructure as possible. That slide feels like it should be somewhere else, but definitions. Infrastructure, actually, we probably should stop to define this. Infrastructure is what I think of as the software that you have to do in order to get the software that you want to do, right? There's your crown jewels, the software that defines you as a business, you know, the code that's your product code. And then there's all the code that you have to depend on in order to build and run that code. And you know, for most of our history in computing, that has been a really big job, right? Like I'm old enough to remember when, you know, we were running MySQL in data centers and I had to like call a taxi to go to the data center in the middle of the night to like flip the switch because it died or something, right? And what we're seeing like in the cloud years is that the infrastructure category that you have to have expertise for in your company is getting smaller and smaller. You no longer have to have hardware, people who know how to do hardware or like data centers. You no longer, for the most part, need to have people who are experts in like operating systems and all this stuff. But the category of infrastructure, the stuff that you don't write, but you have to run and support, it's never going to go away completely, right? Even if you're using a PaaS or IaaS or whatever, you still have to, there's still software that you depend on that you need to own that you don't write.
Yeah.
And
sorry.
No,
The way I think about this stuff is it's the stuff that you wish a vendor would provide to you. You wish you could just pay for someone else to do and you could get exactly the API you want. And then the stuff that you're actually running and maintaining is that gap between what vendors have available and what the interface you need to provide to the rest of your engineering teams is.
Exactly. So like philosophically, you know, engineering cycles are the scarcest resource in every organization. And, you know, if you're a leader, I feel like it's your job to make sure that those cycles, those precious cycles, are being spent on your core differentiators as much as possible.
Yeah, we do have a question from Jason. I'm not quite sure. I think you're trying to ask where's the line between ops and engineering?
Is this about the specialization thing?
Yeah.
Yeah, you're breaking down the lines of roles, right? And everyone's an engineer, everyone's, you know, in the solution to fix it together. But I guess more of a question like, but there is a line, right? You're just saying it's within the engineering influence, not that everyone takes on any role in the company, which is true in a startup to a certain extent, but from the purpose of this talk, that the silos are broken down. You're not a UI engineer, you're not a backend engineer, you're not an infrastructure engineer. It's kind of like the DevOps model where as long as you're suffering the pain and have the ability to inject solutioning, you're part of the, I don't know, engineering universe, where at least you think you can make an enhancement, a change.
Yeah, I think that's right. I think that, like, you know, there's you want to pair responsibility with the ability to change things, right? Like you want to responsibility and accountability, right? You don't want to hold people responsible for things that they can't impact or that they can't own, right? And by saying that everyone needs to care about operations, because if it's everybody's job, then it's nobody's job, right? There can absolutely be point people or point teams for various things, but that's different from being like, they have to care about it. They care about it, so I don't have to, right? I think that, I mean, Jess, you probably have thoughts here too, but I think that a lot of this mindset shift is like shifting from you own it, so I don't have to care about it, to like you're an expert, so you're like my consultant in how I can do this better.
Yeah, I think about it a lot like, as I was saying, like the front end experts on an engineering team, right? It used to be you'd maybe have a front end team and a back end team, and now you often have teams where people are mixed together. And there's still people with different expertises and specialties, and there's still people you go to ask for help. But if like all the work on the team in any given moment is more, say, on the front end stuff, people who are more back end heavy may pitch in, and they're going to be in more of a support role, and vice versa, right? And you can see that with people who are more ops heavy and more engineering heavy, or software writing heavy, because it's all engineering. And it gives that opportunity to flex back and forth, and for people to not have to pick kind of one track or another as much inside those teams.
Yeah, or like maybe you're a product engineer and your specialty is mostly back end, but there's a front end element to your feature. And so instead of going, oh well, it's over on that side, I'm not going to touch it, you know, you can build it and ask for help and best practices and like conventions and everything. And I feel like this is especially applicable when it comes to operations, because there's no such thing as software that doesn't have an operational component, right? There is software that doesn't have a front end component, but everything you write and put in production needs to run well and be maintainable. Like there is no such thing as software that doesn't have an operational aspect.
Do you put that through some type of a filter, through something that I think of security as a nice example, where a lot of people have no clue about, you know, what different security considerations to have, especially in the world of automation, where your build server, whatnot, you know, can have God access to do anything. It's a great attack vector. But does it get, when you make a change, when someone makes a change or touches something that's not in their wheelhouse, does it still flow through a review process? Something who may be able to take a, like, you shouldn't really do that, or, you know, some guardrails to enable safety for those that aren't as familiar in the area they're touching?
For sure. I mean, Jess probably has lots of thoughts about this too. Now, like, there's no categorical answer to anything, right? Like, this is always going to depend on your team, your product, like the areas of ownership that you have. But in general, absolutely, you want to, like, every area of ownership should define a review process, and like, it's about enabling adjacent teams to work in your area and supporting them, not being like, no, you can't touch it.
Yeah, and just like you'd have a security person at a design review, you should have someone who's a DevOps expert, like who has that knowledge at a design review, or like someone who understands how the whole system scales and interacts, right? I think it was, who was it said anything? Daniel, or no, Sam was talking about pull requests across different parts of the company, and yeah, I really like that model.
Same for architects, absolutely. Timely comment. Yeah. As I gotta address this thing about the socks though. This is a very common thing that I hear, and it's not true. There are absolutely ways. This is the kind of thing that gets cargo cultured around from one security team to another without actually examining the source. If you want to do it, there are absolutely ways. Thank you, Pam.
I'm not saying there's not a way. I'm saying that the teams that I work with today simply do not understand the mechanics of being able to do it that way.
Oof. Well, I personally wouldn't work somewhere that but
I got to pay my bills.
I understand, but boy, that would be frustrating. Mm-hmm. All right, let's move on. Keep the comments and questions coming. This is fun. Now, there was this very clickbaity thing that was going around Twitter for a long time about how DevOps is dead, platform engineering is the future, which made me incredibly angry, and it's exactly what spurred me to write that blog post, because I mean, DevOps will be dead the day that there is no longer an ops team or a dev team that needs to collaborate, which is just to say, like, maybe in 50 years, you know, I I find that very annoying. You can talk about new patterns without having to cast shit and shade on patterns that are established. But like for people like when I was like a baby engineer, like there was a need for a lot of just generalist ops engineers. Like I started out running mail and DNS and, you know, NFS. Who remembers NFS? Right. And like increasingly, like those people weren't needed. Like we've been through this great sort, right? Where if you really want to work on infrastructure, you go work for an infrastructure company that's solving a category problem for the world, right? In fact, I think that's yes. If you love infrastructure, you join a company that builds infrastructure as a service. If you love building systems, though, I think there's a huge need for engineers that have this kind of operational expertise to join companies, especially on platform teams, and use your knowledge to help them build great products using as little infrastructure as possible, which is harder than it sounds, it turns out. Which brings us to, I think, the meat and potatoes of what platform engineering really is. Jess, you want to kick us off?
Yeah, so as we've been saying, this is an evolution, right? This is taking the same ideas from ops, taking the same ideas from DevOps, outsourcing as much as we can to vendors. And then there's still that gap, right? There's still that gap we need to do. And then you need people who are thinking about your system and the scaling constraints and how that all works together and can work with the engineering teams. So you need people who can think in an ops way. You need people who can think in a SWE and can talk to SWEs well, right? And you need people who are thinking about what the product engineering teams need, who are interrogating them like a product manager might, right? Like a product team might, because those other engineering teams are your customers as a platform engineering team, right? You're trying to build the right APIs and the right abstractions to enable them to go as forward as quickly as they can, as stably as they can.
Yeah. No, when I was growing up as an engineer in infrastructure, we never had product managers. We didn't we didn't operate like it was a product at all. You know, what we worked on was very much driven by what's on fire today, right? And there was always a stack of things that were on fire. I think we're kind of evolving out of that stage as an industry, like knock on wood, fingers crossed, right? You know, the future is here. It's just not evenly distributed. But in general, we've actually gotten better at learning how to build resilient systems, and the tooling has gotten better. You're able to operate so much farther up the stack than you used to be. And I feel like this is a gap that a lot of engineers like me have, which is just like knowing how to work with product folks and you know, project planners and designers. So, you know, this is something that if I was an engineer right now, I would be leaning into pretty hard. Jess, I know you come from much more of a product side.
Yeah, I come from more the product engineering side, and I got into this type of thing because I was like, I write code and then miracles occur. And maybe like that's not a good professional stance to take. Maybe there shouldn't be miracles between like the code I submit and things actually running in production. And I bet a lot of the SWE teams you're working with are feeling the same way. Like, I write code and then a miracle occurs. You want me to learn all that? That's big and scary, right? Like, that's a whole nother job description. So that's why those abstractions are needed to like bridge that huge gap, right? Because like there is so much that goes under the hood to make even a really simple app run in production, as you all well know.
Yeah, I feel like for me, one of the defining things between like a senior engineer and non-senior engineers is senior engineers understand that your IDE is not software. What you see when you're writing code is not the story. In fact, it's just like chapter 1, right? And I think this is actually a really great interview question, is like, what happens after you merge your code domain? Like, what happens? It tells you a lot about what an engineer knows. And And I personally find it just so fun, like the whole toolkit of like inspecting what's happening in production. It's like a set of superpowers. It's like it's a rabbit hole that goes deeper and deeper. But like being able to like SSH into a box and run strace and go, oh, it's calling all of the. I don't know. It tweaks that dopamine switch in my brain really hard.
Well, and your product engineering teams need to know how their code is working in production. They need to know who's using it, how much, right? Like all that interrogating production and understanding what's going on in production is what the SWE teams really need to be doing their job as well as possible, because they need to know what they're responsible for it, right? In this world where you write it, you own it. You still need to know what's going on, right? You have to debug things. You have to know if people are actually using it. Was your product a success? Was that launch a success? And so when we have more of a divide, it actually keeps the product engineers from fully doing their job, even though they may not realize it.
Yes. How do you know that it worked? The other great question is, how are you going to know when it doesn't work? When you're instrumenting your code, like asking from the perspective of your future self, like when it inevitably fails. This is another, like, I feel like defining a difference between front-end engineers and back-end engineers. Front-end engineers will say, if it fails, and back-end engineers will say, when it fails.
Unless IE is involved.
Yeah, that's a good point. Okay, I'm going to move on a little. Operations teams, blah, blah, blah. Yeah, this is another of those perspective shifts where, traditional ops, DevOps, SRE teams, your mandate has been SLOs. How well is the system performing? How well is it able to execute my code? Like that's what you're accountable for, right? Like what is the percentage of requests that could complete within, this latency and with success? Platform engineering teams, and this is something that I think takes a while to fully internalize. Platform teams are not necessarily responsible for external facing SLOs and user experience. You're responsible for developer experience and the ability of the engineers that you support to self-serve and self-manage, and they are the ones who are responsible for the SLOs and the customer facing stuff.
Yeah, I mean, you could think for a team that's really, really living this, and I haven't seen this in the wild yet, but like in theory, your platform team could go on to an offsite for a week, right? And like not deal with production maybe, right? Like in the platonic ideal, which does not necessarily yet exist, right? Like, because if you're building those tools and self-serving, like you're not necessarily in the heart of those critical loops. And these same people on the platform engineering team, might be your meta ICs that help coordinate complicated incidents and stuff. So I'm not saying that's an anti-pattern, but just to really internalize the shift.
Yeah, exactly. I think that yes, I think it's super important to distinguish, as Justice did, between the aspiration and the reality. And, the reality is that platform engineering teams are likely to be where a lot of your operational expertise is located. In fact, I think they might be one of the only few teams like remaining that explicitly need to hire for as much operational expertise as. And in fact, this is one of the most common failure scenarios that I see for platform engineering teams, thinking the only skills that they need are software engineering. That will fuck you up so hard. You need operations experts who can write some code, and you need software engineers who know some operations. And over time, skill sets blend and everything. But like your bread and butter is like deeply understanding distributed systems. But like I said, the aspiration is that, like Jess said, platform teams can like leave and engineers will self-serve. The reality might not yet be there, but I think that this is another of those common failure scenarios where platform engineering teams lose sight of this and fall into the trap of being everyone's ops monkey. Like you can't do that. It doesn't scale. And it doesn't ultimately serve. It doesn't serve your users, doesn't serve your engineers. If you're always like catching the ball for them, they're never going to learn how to do it themselves. And you being the bottleneck for all of this stuff does not scale. It doesn't help anyone.
No, and the way it can scale, like Derek asked a really great question about like, okay, so how does it work for like a database? And so for example, internally right now, one of our teams in the platform org is writing some abstractions around our main database because we had a lot of systems reaching in and like running SQL directly. And so we're defining a better API around it. We're wrapping it in a library that includes caching, includes much more structured requests that are more normalized and more predictable so that different systems across the company can be getting the same data. So yeah, I would say that taking something like a database or Cassandra and wrapping it up and providing the right abstractions for your company could totally be platform engineering work.
The comment track here is gold. I'm really enjoying it. There is a question here about what might this look like in an R&D function of 10, 100, 1,000 people? Any differences between product and corporate business? I don't understand that last part. Any differences between product and corporate business? Oh, you mean any difference between, like, Colin, can you explain that?
Yeah, so it's kind of like tech companies versus banks.
Oh, gotcha. I mean, yeah, I think that matters a lot, you know, and also, like, if you have an infrastructure product, then a much larger percentage of your value add is going to be, you're literally the ops. Like we like to say that our ops team works at AWS, right? Like if part of your core value prop is doing ops as a service, and you're going to need more there. Jess, do you have thoughts about this?
Yeah, I mean, I think as you get to a larger company too, the complexity of the platform that makes sense for you is probably going to be bigger, like so that you probably have a bigger platform team and it makes more sense to invest in specific tooling, right? Like at a smaller company, you're going to grab an off-the-shelf CI/CD tool and maybe do minor changes on top of it, right? If it's a really big company, you're probably going to do a lot more customization because of history and all the complexity of your system.
This is a really good point, though. I think that we should write a blog post just about these common failure scenario traps that platform teams run into.
That would be fun.
Right? Because I think another one is allowing themselves to own too much code or write too much code or own too much software, right? I think it's super important that platform teams not own large products, or like, you know, if somebody has to write like a custom, say, HTTP server or whatever, even if that's initially the platform, like they can't own software products, right? The best platform engineering teams in the world are I think the ones that write the fewest lines of code, but every single line that they write is like necessary.
Well, I mean, the way I think about it is all code has a cost to maintain.
Yes.
Right. And you already have the cost of maintaining the relationships with all the vendors and keeping that alive and healthy. And so you want to keep as much time available to figure out what else is needed and consult with the other teams across the company, right? So the more of that's eaten up by owning software, the less you have for the rest of it.
Platform engineering is an incredibly high leverage place to sit. And I think a lot of it, you know, vendor engineering is not the sexiest sounding job, but it's incredibly high leverage because you're in a position where you are unlocking the work done by tens, hundreds, thousands of other engineers for your own company to use with just a few lines of code and maybe, you know, a few hundreds or thousands of dollars. Like the value in that is unreal. It's so much cheaper than anything you could do in-house, right? But like making the right vendor choices, integrating them well, you know, creating the right amount of glue code between the systems so that your developers have like a consistent interface, maybe some pre-baked libraries, some helpers, some patterns, is like, it's very high leverage. It's something that is hard to do well and easy to do very terribly.
Yeah, and it's a constant thing because the tools keep shifting and changing, right? There's all sorts of experiments to run, right? And it can weirdly be a place where you actually can end up really involved in partner relationships and
Yeah.
marketing, like co-marketing with vendors if you're on the cutting edge and really pushing them. Yeah, I think about it as like we have really amazing Legos these days, which are these vendors, but like you still have to pick the right Legos and combine them to make something that's coherent and makes sense. So like there's so much skill involved in it.
Yeah. The most senior, the engineer in the world that I worship the most, his name is Mark Callahan. He's a database engineer. He was at Facebook. They invented level 10 for him. He is my Lord and Savior. Like, this guy is amazing. He was personally responsible for, like, I think he was personally responsible for MongoDB doing its IPO, because he was the one that introduced them to WiredTiger and made them do the pluggable storage engines, without which they would have been like, the dude is just, I worship him. He's amazing. He's also super nice. Sorry. Anyway, his main job is vendor engineering. It's connecting teams. It's knowing where those leverage points are to like connect, make this introduction, guide the team to, write this, this pluggable storage API, and like, the dude doesn't work like 80 hours a week. He works like maybe 30, 40 hours a week, but every single minute of his day is fucking precious. Like it's an incredibly high leverage place to sit. This also like points to the fact that I feel like DevRel can be a really important skill for platform engineering teams, both internally facing and externally facing. It's not enough to just build the thing. You've got to get people to use it.
Yeah, or like you want some of those skills and those partnerships, and which is handy because the DevRel team probably wants to talk to you anyway, depending on what type of company you're at, because they want those stories potentially. There's two questions in here that I think really relate to each other. Sam said something about how kind of the old model of ops owning all the alerts and being the hero is how you lead to divorce and burnout, and thus like providing a platform and tools is how you can have a sustainable culture, which relates to Garcia's comment about should low-level alerts like an endpoint down or a table or partition full flow directly from the platform to the product or codes owner. Yeah, right? Like whoever owns that endpoint, whichever developer team is responsible for that piece of the API is totally the person, the on-call that should be woken up, right?
Like so much of like a socio-technical system, like I feel like the job of leaders in socio-technical systems like this is, it's the engineer's job to work within the system, and it's leaders' job to work on the systems. And the feedback loops at the heart of a socio-technical system like an engineering team are, deploys are one, code reviews are one, but this the alerts are another one. You want those feedback loops to be tight. You want them to be, coupled. One of the best things that I remember doing at Parse was making it so that, we started doing a deploy every time an engineer merged a diff to main. And then if a paging alert went off in the next hour after that deploy, we would alert the engineer who had just pushed that change. Right? Why should it go to on-call when 99% of the time it's going to be the person who just made that change? And it made everyone happier, right? The developer wants to know if something broke. It shouldn't have to be proxied through another level of engineers, right? The on-call is like, they're just like a pass-through proxy in that case, right? Looking at who gets the alerts and who's empowered to act on them is a really important scaling function.
Yeah, and that relates really well into the question you were asking, John, about how do you transition from ship it, run it to ship it, run it, right? Like where the team that's writing the code is responsible. Like what does that cultural transformation look like? Because you're right? It's not just a tools problem. It's, as everything is, the people, the cult, which is the culture, the tools, and the processes all together. And so we actually did some of this recently because a lot of the stuff was already, the people writing it were running it, but there were a few things that historically had not been moved over. And so we had to sit down with the team and the manager and get their buy-in that they should be running it, right? And talk through what all the pros and cons were. We had to make sure product was looped in because it was going to temporarily slow down that team's roadmap, right? Because they were taking on more work. And then we did a bunch of stuff with them shadowing the current teams on call, right? And then we did reverse shadows. And then we kind of backed off the reverse shadow to like page us if you need us, right? And it's so amazing how fast it's been, right? Because all of a sudden they'll get pages and be like, oh, I know how to fix this, right? Like not just the way that the SRE team had been fixing it, but like really restructure the code so it never even got close to there, right? And like there's one thing where the SRE team had been running something and like figured out how to get a 10x performance improvement, and then it went to the development team that owned it, and they're looking at a 60x improvement because they can do a more complicated, like they can do a change that requires knowing the system better, right? So
this is like the goal of putting software engineers on call for their code is not, it's not just like sharing pain. It's not like, well, we've been doing this for years, so now it's your turn to suffer. The goal of doing this is because they're empowered to make better changes. Like the people who know it, the people who build it, the people who are intimately familiar with it are always going to be the ones who can fix it the best, right? It just, it makes there be a lower amount of pain, much less pain overall for everyone.
And the fixes can be so much deeper, right? You're much less likely to be throwing Band-Aid fixes on.
Exactly. There's something I was going to say and I completely like spaced on it. Sebastian was asking what?
We have someone raising a hand.
I have a question. Hi.
Yes.
Nice to see you. When we were talking about vendor engineering, that was like a big aha moment for me. And I'm not an engineer, so I'm sorry if this is like obvious for everybody else. But is that something that like engineering teams and engineers really care about? Is like, who's going to be the vendor engineer to make sure that, you know, this tool talks to this tool and this tool? Is this something that's on people's minds when they're evaluating things?
Not as much as it should be.
Okay. Yeah, I thought it was interesting because you mentioned that you could leverage hundreds of engineers outside of your organization to help.
No, this is not typically seen as high prestige work, is my impression.
Except for a few really high visibility choices. Like I'm thinking about, like I was working at a healthcare company and we were trying to figure out what like medical system to use for the doctors to go into. And it was like involved the entire executive team in the decision, and like choosing that vendor was super high stakes and super visible. But a lot of vendor choices are really behind the scenes and not given the attention they deserve.
Yeah, and it just has a reputation, probably a well-deserved reputation for being a lot of just like kind of grunt work. And I think that integrations are getting better. I think that software is coming a long way, and I think that I keep trying to raise the profile of this work because I think that it is undervalued and underappreciated. Let's see. Yeah, I think this is worth underlining again. You know, your engineering cycles are the scarcest resource that you have. Platform engineers, you know, should be the ones who can really help you move as much work that is not core to your business off of your plates as possible. Money is so much cheaper than engineering time is, like almost always. If you can pay someone else to do it, because if you think about it, the things that are your core business are the things you're going to be the best at, because your success depends upon it. And the things that are not your bread and butter are going to be, you know, second thought at best. You want to be using services from teams who it is their bread and butter to be the best in the world at the thing that they are doing. This is an interesting example. I think of, you know, this is just one example. There are many, but like for observability teams, you know, observability is one of these things that if you're writing software, it's going to be something that you have to care about a lot. Oh, I remember what I was going to say. We were back there on one of those slides, and I was going to say something about how observability is actually really when it comes to ownership, right. When it comes to like platform engineering teams, asking other engineers to own their shit, it can be really hard to do that if you don't have observability, because in addition to helping engineering teams own their stuff, they have to be able to debug and understand their stuff. And if you're using kind of old school ops metrics, like those are speaking the language of like low-level Linux functions from /proc, right? There are 4 different kinds of RAM, and here are all the CPU statistics and all this stuff. And if you've got software engineers are kind of like, okay, but I just shipped a change. How do I connect what I just did with the code to what's happening in the Linux user space, right? And like observability tools like Honeycomb, and I think this is becoming more common with other tools too, actually speak to you in the language of your functions and your API endpoints, and it should look familiar to you as a software engineer, which makes it actually realistic for you to ask them to own their stuff in production. I actually don't think with the past generation of tools that it's a reasonable thing to do to ask, say, a front-end engineering team to own their code. If what you're giving them is like Gaily and Prometheus graphs, like you can't really ask people to do 2 jobs, right? You can't ask them to be experts in ops stuff and engineering. You can't ask them to be expert in their area if you give them the right tools so that they can self-serve and understand.
Yeah, it's kind of the difference between CPU usage on the database is going up. You have to figure out what team is even like, where is this coming from? Like half your job is even just like, what's the source of this, versus a specific team getting an alert because they have an SLO burn on latency, and they're able to go in and be like, okay, this user segment right after this last deploy, cool, we know how to fix this, right? It's just a completely different conversation.
Yeah, being able to jump, like not having to like debug all of that from first principles, but like getting something that points you to what's happening in terms that you understand that are relevant to you is a total game changer. We kind of covered this earlier, but like, in the DevOps model, like if your observability team probably would have been running a bunch of software in-house and managing it and spending a lot of their cycles on configuring it and so forth. Observability teams, platform engineering stuff, like early on in the evolution, the platform team might own observability. Typically, as you grow, that will get spun out into its own team. And it would be kind of like a specialized version of the platform engineering team where they're the glue between, one really important vendor and the rest of the engineering teams, instead of like sort of being the generalist glue.
I think of it a lot like testing, right? Like your platform team, of course, is going to own the CI/CD pipeline and make sure the tests are run as part of that, right? But you don't expect them to be writing every test, right?
Right.
So your platform team is going to be making sure you're integrated with good observability tools and making sure there's good ways to see that, and that pipeline and that framework is working. But ideally, individual engineering teams are going to be adding the really key observability as they go. Your platform team is going to be doing the auto instrumentation and stuff to get to that baseline in an ideal world.
Yeah. Dude, the comments, I hope these comments are included in the recording, because they're just gold. There are so many people here who have clearly done this before.
We've got someone
You
with
owe me scotch? Yes. All right. I keep like hitting the mouse over my slides. So this graph was a little bit tongue-in-cheek, and it should not be taken too seriously. But as a comparison between what platform engineers and traditional ops, DevOps engineers, I think that like the percentage of job spent writing code is important. I think that who you build for is important. Internal developer teams for platform engineers versus customers for ops and DevOps. I think if you look at like the list of like where the time is spent, instead of being focused on managing the systems, you're very much running a product process. And anything interesting here that you want to pull out, Jess?
Ooh. Not in this moment. There are lots of really cool things in here. I think the run less software versus cattle not pets is a really nice summary of kind of where people are, because the cattle not pets is really still thinking about at the machine level, right? Whereas write less software is really thinking about what vendors can I pull in? What are the right abstractions? Heck, maybe we're running all on Lambda, right? Like the
Yeah.
cattle not pets just isn't relevant anymore if you're depending on what abstractions you're using.
I think it is important to call out though that it's not these are two different scenarios. These are two different sets of requirements, right? It's not like the teams that have been doing DevOps all along should switch and do platform stuff, right? Like if you're still in a world where you're doing a lot of automation and configuration, everything, that's not necessarily a bad thing. You should do that. That job needs to be done. We're not saying that you should replace what you're doing. We're talking about a new kind of set of recs. Your entire org needs to function in this way versus that way, instead of saying that the team that does this should start doing that, if that makes sense. This, I feel like, is really what it all boils down to. This is the mandate for platform engineers, is to build guardrails for your teams, to make it clear and easy and straightforward to do the right things, and to make it hard and filled with friction to do the wrong thing, so people aren't constantly shooting themselves in the foot. And I think we're at the end now. Are there any questions that people want to ask that we didn't get to?
Can you get us forward 2 slides, Charity?
What?
Can you just bump us forward 2 slides?
Yeah.
There you go. Thank you. I want to make sure we had this up before people started bombing out on us. Y'all have a phone. I know everybody has a phone. It has a camera on the phone. Take that phone, point to the screen, take a picture with it.
If you want an eye test,
Google link or some little link is going to pop up from that. Go ahead and follow that link, and we'll get you this right here. Cool puncher. There was one question in chat I don't think we got to, and I want to lob it your way, Jess. What can platforms the question was from Sebastian, I believe. What can platform teams monitor to know they are putting in the right energy and the right efforts? Like, what are their North Star metrics? And I guess I want to add on one more little tiny part of that. How do you get started to do this? How do you know you're doing it right?
Yeah, so those are both meaty, complicated questions, right? Your North Star metrics are going to change with different levels of maturity, right? As someone I think in the comments was saying, like early on, you're probably looking at how much stuff you're doing manually versus how much you're enabling other people to do. And that's kind of more the transition from doing it yourself to becoming more of a platform team. But as Matthew just said in there, it's really the developer velocity. Like, how long does it take to spin up a new service if that's something your devs do often, right? Like, that's a metric I've seen in the past. The key metrics are going to be really, what are the ops types tasks that you're asking your engineering teams to do, and how painful is it for them? How much time does it take? How much stress does it cause? So exactly what the metrics are going to be are going to depend a little bit on the shape of your org. But that's what I would look at. Like, the things you are enabling people to do, are they enabled? Like, or is it still painful? And then you could also look when you're doing the transition, right, to kind of like, where are the pages going, right? Like, but that's more the transition from kind of a centralized ops space to engineers owning their own code. So it's kind of a different culture shift.
Yeah, the DORA metrics, I think the DORA metrics apply to the engineers who are writing their code and owning their services. They don't apply so much to platform engineering teams, right? Because the platform engineering teams, their job is to enable the developers, and the developers' job is to make those DORA metrics good.
Yeah.
So John asked, what's the balance between providing paved roads and allowing teams to innovate and bubble up new ideas about delivery? So I wrote a blog post about golden paths here. and that I think is relevant. You know, when your organization gets to a certain size, you know, if you're an organization that has historically allowed engineers to like solve problems the way they want to, you're going to have a bunch of shit right. Hopefully you don't have both like Ubuntu and Debian or like Postgres and MySQL, but like you can accumulate a bunch of shit. And at some point you need to be like, here's the path. These are the components that we support, that we will run, that we will make sure, you know, have first class support, that have, you know, primitives that, you know, maybe for MySQL, you know, we support, you know, automatic schema migrations, all this stuff. And then if you want to use something else, that is on you to own it and make sure that it's running well and so forth. And, you know, there needs to be a process. Like I think of sometimes there's like a, you know, you have like a sometimes you have a rotating group of like super senior engineers whose job is to periodically meet and review like the technologies that are in the golden path and decide whether or not to add or subtract any. But you can't support everything. I think that I'm a fan of like, you know, not telling people, no, you can't do this, but being like, here's the impact of doing that. You decide whether or not that's something you want to take on.
Yeah, I agree with that. I also think it really depends on kind of, there's the product life cycle, right? Where you like have an idea and you do discovery, right? And you figure out what the right thing to build is, and then you try it and you test it out and you see what the customer response is, right? And sometimes, and then once you figured out the customer response and you've built the real thing, then you tell customers like, no, do it this way, right? Like, don't try to build it your own using our API, as we will break you, right? By accident. And it's kind of similar internally too, I think, right? It's going to depend on where you are in that development life cycle, right? If you're in the discovery phase, you might have 3 different teams trying different things, but with the understanding that down the road, they probably are going to have to migrate to the golden path or they're not going to be supported, right? So it partly depends on where you are in that and how much your golden path, maybe your golden path is old. Maybe it's not actually like, maybe it's causing friction and you need to do another round of discovery. So it kind of depends on where you are in that cycle too.
Totally.
We have Matthew's raising his hand.
I just had a real world example.
Very difficult. It's really hard to detangle like notifications in a monolith. Sorry, who did I interrupt?
No, I was just going to share a real world example. In my last place, we were migrating off Kinesis, which was the golden path, to what we thought was going to be Kafka. And sort of what others suggested, the S3 team, that was what we call the team, stepped into the engineering team to help provide guidance on what you would do if you ran Kafka on-prem versus hosted Kafka. And then we kind of thought through the economics of it, because we knew that once we decided there wasn't there, and if it went into production, I'd have to own it, right? So it was like I was going to take ownership eventually, and I want to make sure it was built the way we want it to look like. So I mentioned this earlier, like it was the key piece was actually the mentorship, so that engineering could do the thing they thought might have the better approach. But we didn't say no.
All right, I think we are at the end of the hour. Thank you all so much. This was super fun and fascinating. And I wish you all the best owning your platforms.
Great to talk to y'all. Thank you for the commentary. Has been amazing.
Commentary is
I can't
fantastic.
wait to sit down and like really read it carefully.
Same.